Hello, Algebra 1. We're still working with system of equations, and today we're doing part 1 of our substitution method. We're splitting it up into 2 days because it can be a bit confusing, but I know you all can do it. So if we go to page 5, we can look at our steps. Today we're only going to focus on step 1 and step 2, just because I want you to get the foundation of this problem before we kind of solve the entire thing. So the first thing for step 1, it says solve the equation for one variable. You'll be given 2 equations during these problems, and if one is not solved for the variable, you need to make that happen. So, for example, say you have x plus y equals 3, and x minus y equals 4. Well, you could solve for one of those. Let's do the second one. We would have to add y on both sides, and then this equation would turn into x equals y plus 4. That would be your possibility. A lot of the examples that we're going to throw at you will already be in the form of x equals or y equals. So you won't need to do that, but I wanted to show it to you just in case we did throw a problem at you like that. So if we look at our first example, I like it, but I don't love it. So let's kind of scratch this top one out and let's fix it. So what I want to have is 3x plus 4y equals 14. So that's what I want to have. So when we're doing the substitution method, there are a couple big things you have to look for. You have to look for, an x equals something or a y equals something. We need to search for either one or both. But for this example, we have one of them. We have a y equals this 2x minus 3, and that is going to help us out a lot. So we do not need to do step 1. We do not need to solve the equation for one variable because it's already done so. So our next thing to do is step 2, which means you need to substitute it in the equation. So since our first one is, y equals, well, we want to substitute that 2x minus 3 in our y for our second problem. So we'll have our 3x plus 4. Now here's the substitution part. You're putting in parentheses. Make sure you do that. That's your 2x minus 3. And then equals 14. All we did was take what we had equal to y and substitute it in for y. And as you guys can see, our goal, which we met, was to get the same variable throughout the equation. We have just x's in this problem, so that means we could solve for that variable. Well, how would we do that? First step would be to distribute that 4 through to both terms. So our 3x would come down, plus 4 times 2x, which gives you 8x, and 4 times negative 3, which gives you negative 12, and then equals 14. Well, back to kind of day 1, where you have to combine your like terms. Well, here's an x, here's an x. They're like terms. Let's combine them together. So we have 3 plus 8, which gives you 11x, and then minus 12 equals 14. And like I said, I want to stop here just because I want to focus on those first 2 steps. So that's our first example. Let's go ahead and jump to example number 2. So it's asking what the solution is. So remember, we're looking for, an x equals something or a y equals something. But as you can see, we have 2 y equals. So what it's saying is both of these are equal to each other because it has that y equals. You could still substitute it, but you've got your 3x equals negative x minus 32. So it's kind of setting them equal to each other because they're both equal to y. Well, the next thing you got to do is get your variable on one side and your number on the other. Well, how are we going to move over this negative x? We know we have to do the opposite, so we're going to add x to both sides. Remember, you can draw that line. And then you're going to add down. So if there's not a number in front of an x, we know there's a 1 there. So 3 plus 1 gives you 4x, and it equals negative 32 because these 2 terms will cancel out. And like I said, we're going to stop there. because I don't want to solve for x yet. That'll be for the next lesson. So that's example number 2. Example number 3. Remember our first step, we got to look for an x equals or a y equals. And we have that. We have an x equals. And it equals negative 2y plus 4. So we know we're going to substitute that in for this x here. So we've got 3.5. Then our parentheses, because this is where we're substituting it in, minus 2y plus 4. Back to the original, plus 7y, and then equals 14. So go ahead and distribute that 3.5 through. You'll get a negative 7y plus 14 plus 7y, that's a 7, equals 14. So like I said, we'll stop there. But this is what I want you guys to start seeing, is that, hey, we're solving for one of the variables, so we need these to match. And in this one, we have just y's. So we should get y equals something. But our first objective is to look at what we're starting with, whether it's x equals or y equals. And then last thing, with example number 4, we've got to look for our x equals or our y equals. And we have a y equals. It equals negative 5x minus 17. So that means we're going to substitute it in for this y. So our original equation, we've got negative 3. Then we'll have our parentheses, negative 5x minus 17. Back to the other one, minus 3x equals 3. Well, remember, how do we solve for these? Distribute your negative 3 through. So you'll have 15x plus 51 minus 3x equals 3. Remember, you do not distribute that negative 3 to the negative 3x just because it's not in parentheses. Next step is to combine your like terms. So we've got a 15x and a negative 3x. Well, that gives you 12x plus 51 equals 3. And I'm going to stop there. So that's what I want you guys to focus on today, is taking your y equals or your x equals and substituting it into the other equation so we can have one variable in that equation. And then tomorrow we're going to put it all together of where we can solve for both variables. But if you guys have any questions, make sure you go ahead and check off your first booklet for the substitution method, and we'll finish all of this tomorrow. Okay, goodbye!